Our third review video for Chapter 4, we're going to review three sections, 4.3, 4.4, and 4.5, which all basically deal with factoring. So again, on the chapter review here on pages 319 through 320, we're going to take a look at problems 16, 18, 20, 22, 24, and 26. And I think that should be a good review of how to factor in general. All right, so taking a look at number 16, okay. So 16 says we're going to solve the equation. So we have z squared equals 63z. So when we have an equation like this, the first key is to make sure this equals 0. So we're going to subtract 63z from both sides. So our new equation becomes z squared minus 63z equals 0. Now the next thing we take a look at, notice we only have two terms. Here we're going to do a concept called greatest common factor, or GCF factoring. So between z squared and negative 63z, we look at what's the greatest common factor between both of these terms. And that's a z. So we're going to factor that out, and then we write what remains. So when I factor or divide by z, I have a z left minus a 63. And that equals 0. Next, we're going to use the zero product property and set each factor equal to 0 and solve for z. So we have z equals 0 or z equals positive 63. And then we can write that as a solution set if we would like. And there's your answer. Okay, taking a look at number 18. We have the equation k squared plus 12k minus 45 equals 0. So when we have three terms, what I like to do is the guess and check method. You can do the box method if you like. Okay. Now, we will think about what factors of k squared can I multiply together to get k squared. Well, the only way I can do that is k times k. And then we think about the factors of negative 45, okay, that could add up to be 12. So negative 45, if I write to the side, obviously 1 times negative 45, and then vice versa. And then I could do 5 times 9, okay. How about 3 times 15? And then one of these have to be negative. And then, of course, we can flip the signs. So then let's do negative 1 times 15. And then let's do negative 5 times 9. And let's do negative 3 times 15. So we look at all the factors and which factors could possibly add to give me a positive 12. And that's negative 3 and positive 15. So that's what I write here. And then remember, we always want to check by FOILing this out. And when you do that, you actually get the right answer. So you have k minus 3 equals 0, or you have k plus 15 equals 0. And in solving, you have k equals 3, or you have k equals negative 15. And then you can write that as a solution set if you want. And there's your answer for number 18. So moving on to number 20. Okay, so number 20 is the equation n squared plus 5n equals 24. So again, this must equal 0, so we first subtract 24 from both sides. So we have n squared plus 5n minus 24 equals 0. We draw our two sets of parentheses for the guess and check method. We have n and we have n. And again, we think to ourselves, what are the factors of negative 24 who could possibly multiply together and then when added give me 5. So I have that. I have 3 times 8, and then I have negative 3 times positive 8. Oh, I think I could stop. I found two factors added together to give me positive 5. So I have negative 3 and I have positive 8. Then I set each factor equal to 0. And I'm solving, and I have n equals 3, or I have n equals negative 8. And then again, we can write that as a solution set if we want. All right, moving on to number 22. So 22 goes to the next section and might get more complicated. Who knows? So we have 3x squared minus 24x minus 48 equals 0. Okay. So taking a look at this problem, what I noticed from the get-go, I can divide everything by 3 to simplify my problem. So when I do that, I have x squared minus 8x minus, that's going to give me 16, is it going to equal 0? Okay. Let's see here. Factors of 16, of a negative 16, that when multiplied together and then when added, let's see here. So negative 16, we have negative 1 times positive 16 and vice versa. We have 2 times 8, and then we have 4 times 4. None of those combinations could possibly add together to give me negative 8. So we have a little situation at this point. Now, when we're teaching this section, what I probably would have had you say for this is that this is prime factored. We can't factor this any further, and which is true. So can't be factored, and you would be done at this point. But this is an equation, and we can solve it. So there are 2 methods you could do, and this is a different section: complete the square or a quadratic formula. The quadratic formula is probably easy for most of you, so let's just go ahead and do the quadratic formula for this problem. And then when we do that, we get 8 plus or minus the square root of 64 minus 4 times 1 times 16 negative, all over 2. So we have x equals 8 plus or minus the square root of 64 plus 64, all over 2, which is going to simplify to give me 8 plus or minus 8 square roots of 2 over 2, which gives me 4 plus or minus 4 square roots of 2. And there's your 2 answers for this problem. All right, so then let's take a look at number 26. All right, and then 26 gives us the problem 5y squared plus 4 equals 14. And this one says solve by completing the square. If you notice, there's no bx term, which gives you the big hint that you want to use the square root method. So subtract 4 from both sides. We have 5y squared equals 10, and divide both sides by 5. So you have y squared equals 2. Now the key with the square root method is you're trying to isolate or solve for the squared term, so that when you have the square term by itself, you can simply take the square root of both sides. And when you do that, you have y equals plus or minus the square root of 2. And then we are done. And that is the quick review of factoring.